have to say. But I would like to make an excursion in the time before digital art was even a word invented. When I went to art school in the late 50s, let's say, the art of the time was an art which was a very emotional art. It was art which did not think but act. It was action art, it was gestural art, and all these things were very important to me. And at the same time, I was also a jazz musician at the time, so music and art was always my background. And then suddenly one day, I don't know what happened, I started reading this philosopher, Max Benson, who teaches in Stuttgart, in Germany, and he talked about rational art. So what's that? I come from a very emotional art, gestural, and now this guy talks that art should be rational. So for a very long time I had to think what this means, and I could not figure it out. But slowly I saw in my own art that this kind of thinking, what should rational be, showed up. And I'll show you now, up to that moment, what I did at that time. So I did this kind of art, very unsystematic. I was always into writing and music scores and this kind of stuff. And then suddenly, you see the little geometric signs. Suddenly, there were signs coming up. I didn't really know what I'm doing there. And I thought maybe that's rational. And I went on. And at one point, this geometry took over. So what I did at that point, I cut out of black cardboard little pieces of paper, and I moved them around on the surface and created sort of compositions like these. These are paintings. But at one point I thought that this can't be rational. Even though it's drawn rationally, there is no content to it, there is no rational content. And then something very interesting happened, because I lived in Paris at the time, and I met a composer who wrote computer music. And that's a shock. So he wrote programs to write music, and this is the late 50s. So he gave a conference, a public conference, and during that conference I suddenly understood what it means to be rational. And I saw that it's not to cut out a form and make a composition, it's to create a logic which creates this form and the composition. So not the form itself, but before the form is created, I have to find a logical instruction. That means I have to program something. So that was the first step that I understood. That's exactly what I would have to do to be somehow logical. But the problem was in 1967, where you couldn't learn programming nowhere. There was no school teaching programming. There was no computer, nobody had a computer. There were only a few big companies who had big computers, twice the size of this room, air conditioned, and millions of dollars of hardware. So nobody could go there. So how could I do something? And I asked, I got friends with Mr. Barbeau, the musician I met, and he said, I'm working at Honeywell Bull, but I can't let you in there because it's impossible. You have to find your own computer. And for some other lucky strike, one evening I was watching television in the news. They showed that just last week, the Meteorology Institute in Paris got a very big machine which draws the weather curves. And that again, I said, that's where I have to go. So the next morning I ran over there to this computer center and I asked how is it possible that I could do something here? And of course it wasn't so easy, but they were very nice and told me to write a letter to the Ministry of Transport and so forth. So I did all that and lo and behold I got an answer. I had a meeting with the Minister of the Transport of France who was very nice to me, and to make a long story short, he granted me access to the Meteorology Institute, but only at night, because the programmers go home at night. So that was heaven for me. I mean, I probably was in 1969, it wasn't 69, the only artist in the world who had such a paradise. I had the biggest machines I could use, had a plotter of 5 foot by 3 foot, and the only disadvantage was that I worked at night, but I didn't mind because I always worked at night. So I started writing program. And the first program, of course, I wrote was a random number routine, because at that time no computer had a random number routine yet. So I did, the first thing was I built a sculpture, I made also drawings with random numbers. And then, once this worked, I mean it wasn't so easy, you had to debug and whatever. Anyway, once this worked, I went into plotting. Here I printed out the random numbers, I made a book of random numbers. And then I started drawing. I started very simple, horizontal and vertical lines, and I distributed them with probabilities, like 100 lines, half of them have to be vertical, half are horizontal, and the probability of line width, and so forth. And it became more and more complicated, like a random walk. And here comes my musical part back, that I wrote programs that simulate like writing, and I did logical adding and subtracting. I'm going fast through these things because I have so many slides and I cannot show everything and talk about it. So I did all sorts of, here I cut up the program into little pieces like a checkerboard, where each case could have a certain number of lines between 0 and 7 or whatever. And I started drawing and making all this sort of, from a music influenced writing programs. They all are based on some sort of algorithm which simulates writing. I could easily translate these things into a text. It could be a text and so forth. And then I tried with curves to draw things. And I did, every day I had another idea, and I worked, I mean, like crazy day and night to do these kinds of drawings. And then I thought, somehow, I even had then a show at the Museum of Modern Art in 1971, which is now considered the first show in the world of a one-man show of computer, I mean, completely entirely done by computer and drawn. But I thought, somehow this is too easy. I should find something more global. It means my system should be like in a music instrument. If I play on my saxophone, whatever I do, it sounds like a saxophone. So why couldn't I invent a graphical instrument which plays graphics? And I was thinking a long time, and then I suddenly had the idea, well, the cube is a system. It is in itself always correct. So why it could be my instrument on which I play. And then I started looking into the cube, and I sort of took it statistically, taking lines away from the cube. So I created from these 12 lines an incredible vocabulary, or the other way around, like 5% to 90% lines, and so on. And then I made a very thorough study. I draw the cube and took one line away and showed all the possibilities systematically, how they would look like. on the left you see what I took away, and on the right was left. And so forth. I went through the book 2 lines away, 3 lines, 4 lines, 5 lines. It's a completely incredible alphabet. And then 6 lines is symmetrical in itself. And then I started using these elements as elements to add up, like mathematical numbers, like from the 4 corners to the center, I add up the lines, and 3 times the same thing, taking 4 random lines each. At the end, I add up the whole cube. And I did all sorts of drawings there too. Even I made formulas with these lines, that the union equals the sum and so forth. It became a real fantastic alphabet for me. And here too I'm adding things. Or statistically, I build up the cube towards the bottom while the cube is also turning. Or I concentrate the complete cube in the center. Or I had completely random cubes. And I made even a film at the time, but that's a different story. That was too early to make a movie with a computer because nobody had the machines for it, and it was too hard to get access. Some company offered me this microfilm camera, but it took me 6 months to make 2 minutes of movies, and I gave up. So I wasn't interested anymore. And then I started thinking, what is important I'm doing with the cube? And I found out that I want to disturb the symmetry. That means I don't destroy the symmetry, but I derange it and destroy it, but logically it stays there. I like the ambiguity because front and back I'm not really interested. That means I'm interested in creating 2-dimensional signs. So then I started cutting the cube in 2 and rotated each part separately, and I made all this drawing, or I cut things away from the cube and made series of paintings, like here you see. But I was always not interested in going into a movie again because I wanted that the elements are signs where I can go back in time and forward time, like I want to look at something without being harassed by the timing that I can't see. So I like the signs as signs and not as a timing thing. And I worked for many years with this kind of cutting. Here I cut it in 4 and made structures. Here you see very perfectly how I arranged the symmetry because the cube is cut in 4, and the right top and the bottom left is the original cube, and the other 2 parts, each one is turned 5 degree positive and 5 degree negative. So I constructed all this kind of elements, and I wrote a program then to grow on this kind of cut. So it became like a biological thing that I could grow, and sometimes there was an end to it because it couldn't find a place on the cube to grow, or it was endless and I had to stop it by myself. And then I built big structures on the wall, and then I thought, why don't I look into something? For example, here I cut the cube in 4 and then I moved them together slowly. So it becomes a whole series of moving the cube together. And the gray and the white and the black shows where the original inside of the cube was and what is the outside. And then I thought, why don't I go 1 dimension higher? That means that a 4-dimensional cube is nothing else but 8 cubes in the middle. So my alphabet and my structure becomes much more interesting, and I have many more things to do. And I started with a hypercube, but when I saw the first wireframe of hypercube drawing, I found it so ugly and unpleasant that I didn't know what to want to do. So I compressed the whole thing into a square, which I'm allowed to do because all the relations are still there. So I worked with this, and I did I calculated the diagonal path to the structure. A diagonal path is, in a square, everybody knows what a diagonal is. But a diagonal path in a square is if I go through each dimension once, that means on the outside line along from up to opposite points. That means a diagonal path is a diagonal which goes through each dimension once. So in this case, it goes through 4 different dimensions. Each time it takes a different direction, and there are 24 possibilities in this kind of setup. So I made a construction in wood, very big, and I showed how many times I can go through the same structure. Every time it goes more than once, the line became thicker. I made a big drawing. Or I divided this graph into 4 equal parts. If I add them all together, it becomes the sign on the right. And I made paintings out of that. Here I ordered them in a magic square, so I don't even have to make a composition. And I made paintings with the magic square stuff. But then I thought, okay, I hated the view of the four-dimensional cube. But why don't I look back at how it's really as a graph? When I accepted the graph now, because now I got more used to it, to this kind of thing, because I'm never showing the whole structure, always only aspects of it, because it's not the structure I'm interested in parts of the structure, so that the symmetry gets sort of deranged. So I went back to this original structure, and then I tried to understand how this thing fits together. So I took this 4-dimensional hypercube apart and showed the 8 cubes how they are laying in space. And as you might have seen before, I have this inside-outside thing of when a cube gets turned to 0 degree, we only see a square. And that's through all my work, is this a sort of a limit of inside and outside, and it appears all the time in my work. And here I looked at these 8 cubes, what do I see in their 0 position? And that I kept, let the computer move it together again, and I got these paintings. So it became shaped paintings where the rotation of the original cube becomes the shape of the painting. So I did a whole bunch of them. And then I had in the museum in Germany, in the Hut Museum, I had a retrospective where I showed for the first time everything I did until 1987. And it was an incredible emotional moment, because I put things together which had nothing to do with the computer, and I was very worried that maybe it doesn't fit together, but it worked perfectly. So I went even one more dimension higher, and I showed on this. Now I don't even show the structure anymore. I just take elements from the structure. Like here, I take 5 lines from each dimension and show them as painting. And here is the same thing, but now what's interesting here is that this is 10 times the same drawing. That means in 3 dimensions I can look at somebody from the front, from the side, and from the top. So I would have 3 images, 1 eyes, 1 ear, and 1 hair, if you have hair. And in these 5 dimensions there are 10 of these views. So this is 10 times the same drawing, seen from different views, projections. So this is another dimension higher. So now I went back to the idea of diagonal paths. And here you see this is a diagonal path from 2 opposite points. I calculated the possibilities, how many there are between 2 points. And I found out that there are over 720 elements, and I made this incredible, like minimal music sounding drawings. And it's diagonal paths for hypercube. And here I made I cut it out with a laser out of metal, and I made it very big. This is like 50 feet wide. Here in the museum I showed this diagonal path. I've also let the machine choose different, randomly different diagonal paths and put 4 together and cut them out with a laser from a steel plate. And I made these reliefs, which is also some incredible form invention. And I made drawings where I thought I have the balance between a gray line and a black line. The gray line should have the same value visually as the black line. And it's always this diagonal path. And then I took 2 diagonal paths and connected them with thin lines at each dimension. Every time the line has a sort of a bend, I connected it to the corresponding diagonal path when I got these drawings. So now my idea was that if I take the circumference of this thing and make a wooden plate, I can make shaped canvases out of two diagonal paths. That means I invent by choosing which diagonal paths I use, what kind of shape this thing has. And I made this kind of paintings, or I bend metal as diagonal paths. And then I sort of was standing against the wall. I didn't know anymore what to do next because it became so simple that I could not explain to everybody that this is complicated. Because the content is very complicated, whereas the visuals is absolutely new. So I did the following. On the left side you see 4 diagonal paths. When I put them on the right side, I opened them up as zigzags because I had to understand what I'm doing. So I thought that since I create this artificial squares here, this rectangles, I could color them with something. First I tried with gray levels, but it didn't work. Then I let the machine just choose any color it wants because it was not about the color. It wasn't a color painting or color work. It was about getting a differentiation between things to show the complexity. So what I did now, I made paintings, but before I wanted to show this one. To understand what it does, I moved this into the 6th dimension. So before everybody understood what I was doing, but now nobody can understand the thing anymore. And it's not about the understanding, it's about my invention of an image, So then I did some paintings like that. I mean, there are inkjets and canvas. And then I thought if I let this now move, that would be even more interesting because then you would hear some shows how even big I showed them. If I let it move, you even feel even more the spatial relationship of the whole thing. So it wasn't an easy task. It took me like 2 years to even get all the errors out and the exceptions, because there's so many exceptions. It's very complicated. So that was my first animation I did, and then I went to the next dimension, which is another dimension, and I saw that there are 42,000 and something cubes in the structure. So that's a lot of cubes, and nobody can do anything with it. It's too much. So my algorithm was to let the computer choose a certain number of cubes and paint the sides of the cube randomly black and white, and then show the structure, what it does, and it became an incredible structure because the blacks add up and the whites add up. And I made these paintings, and then I also tried to move it, and then it became very clear what's happening here. The thing is that once the pieces are chosen, I mean the blacks and the white are chosen, they stay together and rotate on the structure in 6 dimensions. But since I don't have all 42,000 cubes, there are holes, like in a Swiss cheese sometimes. And that's where you look through onto a green, infinite background. And the forms, it can't be understood, but it's never about understanding, it's about visual invention. And in a sense, the only thing what one could understand is that if you look at a tree in the sun, all the leaves add up to one shape on the bottom. Sometimes there's a hole, there are no leaves. So this is exactly what it happens here. It's sort of like a shadow from the 11th dimension. And then I went back to the diagonal path, also in this 11th dimension, and I let the computer choose a number between 2 and 11 diagonal paths, and let it color randomly too. And here you see also the square, which is my 0 position, which holds the thing together. And I made paintings and all sorts of drawings like this. And then again, I started to let it move. So what I did here, I made a setup where there are 2 screens. The right screen will show the movement, how it changes. And every 10 seconds, there will be different colors and different lines. But a second before it changes, it throws the last image to the left side. So you will have on the right side the movement and the development of a sign, which you can't catch. And on the left side, you have the contemplative sign, which you can look at. And then I made it here, not as a sort of, I show it flat like this. So the right side moves, the left side gets every 10 seconds, it gets an image. So it will come over, now it will be green, see? So all these things are without end. I mean, they will run forever and never repeat themselves. So now my last adventure with the screen, which is called parallel resonance, and that again it's the diagonal path, but now you have to imagine like the thin black line you see there is a diagonal path, but it has an incredible width, which is white. So the white creates a form, and there's the same thing on the back in black, and they're sort of fighting each other. And I made this different paintings, and I also animated it, or I did all the thing without color, only white and quasi white. And and that's how when it moves, it creates these forms. And sometimes the black form exchanges its color with the background. So there's all this aleatoire stuff in it, but the front element always stays white. But to conclude, I just wanted to say that all the rules or algorithms I invent, they reflect me as a person, my thinking and my feelings. But it's not really the system or the logic I want to show. It's what the logic does and invents as visual result. And then also that my artistic goal is reached when when this form can dissociate itself from the content and stand